For the sake of the video, I'll just kind of recap what we did. So the class was given this script, this definition that actually has gaps pulled out of it. And so step one, if you guys recall, which I was very impressed with how you guys performed, was to create an extrusion off of a line that was 25 feet long and had an equal distance of a vertical extrusion. And then step two was to subdivide it into 25 equal parts. Step three was to find the surface normal so that no matter what orientation you change the line to be, it would extrude in that direction, and then extrude them, all of the individual panels by 10 feet. And then step four was to do the same thing with circles. And then cap the circles and feed it into a surface difference where we could then delete the circle volumes out of each of the individual square volumes. So the recap. Here I gave you guys kind of a nudge by dropping that in for you so that I could help you guys understand that you need to find the surface normal. I would not expect you to understand this intuitively, so it takes a couple of times before you remember that you have to go to surface analysis and do a surface closest point with which you can evaluate the surface and find the normal. It's very odd. But the other one that was a bit of a pair that you're going to see very frequently, especially when learning from me, is under or paired up with the subdivide surface, also known as isotrim. And I very, very frequently pair that up with divide domain squared, like this, because those two basically will take almost any surface and it'll subdivide it into equal parts. That's the gist of it. So what we needed to do in order to get there was to actually create the extrusion. And so I threw you guys for a loop, I think, a little bit off the bat by not giving you the numerical value that you needed. I set everything to 0. So both of your points were coincident at the origin. Most of us caught on very quickly to say, what I need to do is actually change this value to 25. And when doing that, it actually will stretch my line across. So 0, both points were at the origin. 25, now I have a line that's 25 feet long, and it's along the y-axis, like you see in the image. From there, I kind of clued you in to what we're going to be doing here by dropping in the unit z vector, which basically means I'm going to use extrude, and I'm going to extrude it 25 feet in the z direction. And so that's under surface, freeform, extrude. So the B input is the base geometry, which is just a curve. And then the V is the unit Z. Okay, were there any outstanding questions on that step? I think we all got past that one. So then the next one, I mentioned these two right here to you just a second ago. They almost always pair together. But the thing that helped me really truly understand how they work is the fact that they actually always create a triangle, those two. So the divide domain is going to take a surface and divide it into equal number of parts that you feed it. So I dropped the 5 in for you. So that way I can just say I want my u and my v to both be 5, which is what you see here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that will subdivide a surface, but then the isotrim supplements the actual action of cutting it into individual parts. And so that triangle is formed just by feeding the same surface or set of surfaces into both. And that gave me this. And if you turned on the area, it would look like that. Were there any questions on that still remaining? All right, good. So now we get into a bit of the craziness. Step 3. So step 3 was find the surface normal of the 25 individual surfaces, and then extrude all the surfaces 10 feet along the vector. So the surface normal, like I said, is always a pair. And you can see here that these pairs, you've got a UV point and then a UV input, right? So it wants to read the UV orientation of a point from one to the other. That, at least in this class, that will always be the case. And then the thing to note here is that it requires a surface to evaluate, but then it also needs a point on that surface that it's going to find the normal for. So that's your first two inputs. So the surfaces that we're going to feed it are these, each of the individual surfaces, but then the points that we're going to give it are those, which are found from the centroid, which is right here on area. Centroid right there. So that one is also not intuitive. And so what I was describing to Anthony earlier is that the centroid is a byproduct of calculating the area. Well, not necessarily, but you can find the centroid with all the same information that you would use to find the area. So they provide the centroid as a byproduct of that. So we plug the centroid into P, but we notice that we still have an error here that says input parameter S failed to collect data. And that's because you need to evaluate the UV coordinates based on the same surface that you mapped your closest point onto. That's a little confusing. I don't expect you to understand visually or intuitively how that works, but I do want you to know that what you're seeing here with these, you're going to see often if you're going to be doing a lot of subdivision, complex assemblies, compound definitions and stuff, the way that we do it in this class. I'll give myself some room here. So then comes the extrusion part. So all this stuff is going to probably slide out. And we need to extrude it 10 feet like you see. But I mentioned that you need to extrude it based on the normal, not just the X or Y axis or anything like that. So it's very simple, actually. I think a few of us found some roundabout ways and took a couple extra steps to get there, but it's okay. All you have to do is just go to Surface, Freeform, and Extrude. And Extrude is going to require the base curve or surface. In this case, it's our 25 individual surfaces, as well as the direction. So the surfaces are going to be these, same as you saw before. Let me pull that down, make this visible. And then the direction is going to need to be supplemented, because if you notice these normals, they have a direction but no magnitude. And so I gave you a hint over here with this amplitude. That is going to give us a numerical value that's associated with a direction to give us an actual full vector. So I'll pull that back. The vector is going to get the normal. And I can plug in a numerical value of 0 is less than 10, or just a panel that says 10. And I'll plug that in to D. So now, at this stage, we've taken the subdivisions, we've evaluated where the normals are of the centroid of each of those subdivisions, and we've extruded them 10 feet. So are there outstanding questions at this stage for that? Nope? I think most of you got that one done. So let's finish this off real quick. The rest of it is very, very quick, and I just want to wrap the video up in one big thought, and then we can explore a few other things. But to do the circles, it's basically the same thing, except we're going to extrude a curve instead of a surface. And then we have to cap that curve in order to make it a solid. So that's what you're seeing over here, where it says cap will create a solid out of your circle extrusions. The other thing I mentioned is that you should be using circle CNR, and then I drop that in for you as a benefit to you, because the circle C and R is how you actually map a two-dimensional geometry, like a circle, onto a three-dimensional, in many cases, warped surface. For our case, it's actually in plane, so it's not that big a deal. But if we want to turn this, no matter where we turn or warp this surface, it'll evaluate the normal, and it'll place the circle tangentially across that surface. So let's take a look at what that looks like. The circle itself is going to be mapped onto the center points. So for us, that would basically just be the centroid again. And then the normal is going to come from that normal, and it's basically going to be the same thing with the amplitude. Oh, I'm sorry, not with the amplitude, like that. And then you can establish a radius. Let me turn this on so you can see it. Okay, so that's where it's going, right there on the surface. And you can establish a radius. For me, what I did was I borrowed the... What did I borrow? I forget what I borrowed. I think I took this. Yeah, so I just plugged in the 5 from the subdivision just as a number, and I just decided I was going to divide that by 4, I think. No, I'm sorry. What? I forget what I did. I did something like that. Yeah, maybe it was divided by 2. Yeah, you're right. Okay. But you could do it any number of ways. You could put a static number in that says radius 2.5 or something like that. So that got us the circles, and then we just have to do the same thing with an extrusion and the amplification. So I just copied the extrusion down. I left the amplification connected, and I replaced it with the circles. Yes?
So can we just get the radius as a 2.5?
Yes. Yeah, you could just type in 2.5, put it in a panel and connect it, make it a slider, whatever you want. For me, I wanted it to be mapped in case I change the size. Okay, so now we've got our 2 extrusions, and well, that was the end of step 4 basically, but did anybody have any other questions about step 4? All right, so let's wrap up this idea, and I'll do a couple more quick questions. So we've got the cap, where we can take our circles, which right now look like this. They're hollow. If I plug it into cap, it solidifies them, like that. And then I take the same extrusions and I plug that into surface difference. And this is what you get, which is the result here. Yes?
I have a question about the amplitudes. You only used 1 amplitude. I just needed to see that, actually.
Yeah. So I used 1 amplitude. Let me put that up there. It's down here. I'll go over it again from over here. So I only need 1 amplitude because I know that both the squares and the circles are going to be extruded the same distance. So I plug the same amplitude into both extrusions. I just changed the geometry. So, what questions do you have? It seemed like pretty much all of us were right on track to getting this done. I'm actually really proud of all of you for how you performed with this. It's not that easy to just, switch gears and go from, following along step by step to actually having to think through how you're going to put them together. I will say this, with all the frustrations you might have had with doing it, it gets much faster. Like I said, the curve, right? It's going to be a very steep curve for a little while. And then by the time you're done this class, you're going to plateau at this really awesome, intermediate level. And then if you want to become advanced, then you're going to need to put a lot more work in. But, you'll be able to do very cool things after this class like this, okay? Or with stuff like this.
Can you say
Yes, I'll show you, but let me stop the video here.